Hello, and welcome to this lesson on solving inequalities using addition and subtraction. And we'll be focusing solely on one-step inequality. So this is going to be a fairly easy lesson as long as you have a good background knowledge on solving equations. And it also should be a fairly short lesson because once you get the idea of how to do this, the lesson's going to fly. And this is the first lesson building up for about the next 5 or 6 lessons on solving inequalities. So make sure you do take your time and take the lesson to heart. So, central question: how do I solve inequalities using addition and subtraction? Straightforward enough. Did you know that solving an inequality is nearly identical to solving an equation? There are a few differences, though, you must watch out for, and we'll not actually see any in this lesson. Next lesson, we'll see some of these differences. Vocabulary. The one vocab word is the word inequality. So an inequality is a math problem where the two sides of the equation, but it's not an equation. The two sides of the math problem are not equal. One side is greater than another. So that is an inequality. 8 is greater than 5. That's an inequality. The two sides are not equal. If we said 3x is less than 15, well then we have a host of numbers that we could plug in here for x that would make this true. As long as this side is smaller than this side, then x is considered a solution to that inequality. And that's going to be our goal throughout this lesson. Now, I have this page called circle type. We're going to put this down first and then make sense of it in a second. So there are two different types of circles we're going to use, or dots we're going to use. We're going to use what I call the hollow dot and what I call the solid dot, or the filled in dot. Some people they say like circle and dot, or empty dot and solid dot, something like that. Now, the empty dot we're going to use when we have just a less than or a greater than. And again, if this is very confusing right now, this will make so much more sense when we get to the next page and actually do a problem or two. This solid dot we're going to use when we have a less than or equal to, or a greater than or equal to. So I'm going to cheat. Copy, paste. There. So that is one of the first big things to learn in this lesson, is the difference between the use of which type of dot. If you have trouble remembering which one is a less than and which one is a greater than, one strategy I use is a less than looks like an L, like a capital L. Like here's a capital L and here's a less than, or if you make it a little bit more bendy, but like it L less than. You could also remember that if you're using the symbol properly, it was like this. Remember how it always eats the bigger number? So that would make the number that comes first less than the one that comes second, which is actually how it gets its name. This is less than that. 3 is less than 5. Okay, but the strategy of using L less than works for me. I like it. All right, so write and graph an inequality. The greatest number of marshmallows Donald could put in his mouth at one time is 19. Use only this fact to write and graph an inequality that describes the number of marshmallows Donald could fit in his mouth. Okay, so The inequality is going to look something like, well, I'm going to use M for marshmallows and 19. So the marshmallows, it's something with the number 19. Is it bigger, smaller, or equal to, greater than, less than? Let's see. Well, if the biggest number of marshmallows he can fit in his mouth is 19, he cannot fit more than that. So he can fit less than 19. The number of marshmallows could be less than 19. But is he also allowed to have exactly 19? The greatest number of marshmallows he can put in his mouth at one time is 19. Yeah, he can have that. So that's why we're going to change this from a less than to a less than or equal to. Now, every single inequality gets a graph. Because we don't just have one number as a solution, we have usually an infinite number of answers. And so the graph goes along with that. So my graph looks like this. Here's how I do this. So this little number line I have made here has 5 lines on it. That's just to keep it so we don't have to graph too many things. You can have number lines with 10, 15 lines on it. It just takes a little bit more time to graph. So I take the solution to the inequality and I put it in roughly the middle. There's no rule saying it has to be the exact middle. It's not wrong if you push it off to one side or the other. It's just, I like it there because it makes it pretty. Now, the next step is you fill in the rest of the number line. So 19, 20, 21, 18, 17. So 17, 18, 19, 20, 21. You just fill in the regular numbers on the number line. There's no rule that says you have to count by ones. You can count by pretty much anything as long as you're consistent on your number line. Now, we're going to put our dot. Now, if you remember from the page right before this, this inequality gets a solid dot. See, a less than or equal to gets the solid dot. So what we're going to do is we're going to put a solid dot at 19. You just put a dot and you fill it in. What that solid dot tells us is it tells us that 19 is a solution to this inequality. Anything that we're going to be shading in is an answer. Now, we want to show the answers that are less than 19, which would be like everything over here, like all of these guys, like 17. He could have 17 marshmallows in his mouth. It's just less than 19. So anything in this direction, we need to show that it's shaded as well. It's part of the solution as well. So what we do is we just shade in our number line. So you can do the ugly method like this. That's what most people do. So this shows that everything in the shaded region, 10, 9, 8, 7, 6, 5, 4, 3, 2, 17, 18, and including 19 are solutions. 19 is part of this shaded region of answers. Everything down here is an answer to that problem. Letter B. The lowest temperature in January was greater than -15 degrees. Write and graph an inequality that describes the temperatures in January. Okay. So the temperature is something with -15. The lowest temperature in January was greater than -15. Okay, so it's just straight up greater than. Temperature is bigger than -15. Greater than. Less than looks like an L. This is a greater than. Okay. Number line. -15. I like to put roughly in the middle. This is a place for people to make mistakes. If you need to, double look up a number line, especially the negative area, because a lot of people go -15, -16, -17, and that's very wrong. On a number line, the bigger a number gets, the more, or when you're talking about negatives, the more negative a number is, the smaller it is. So negative 17 is smaller than negative 15 because it's more negative. Or if you would imagine, if this keeps going, negative 15, negative 14, 13, 12, 11, 10, 9, 8, 6, eventually you're going to get to 0 and 1, 2, 3, 4, 5. That's the right way to go. But some people get so wrapped up that what they do on their number line is they just go 15, 16, 17, 14, 13, and then just throw some negatives in front, and that doesn't work. Okay, so make sure you're paying attention when you're talking about negatives on your number line. All right, at negative 15, I need a dot. Now this is just a greater than, so he gets a hollow dot, meaning that negative 15 is actually not a solution to this problem. It is not shaded in. It is hollow dot. And we are going to shade the numbers that are greater than negative 15. Well, greater than negative 15 would be negative 15, negative 14, 13, and everything this direction. I'm going to show another way you can do your shade instead of the big ugly scribble. Some people like this instead. It's still showing that you're shading this direction, but it's just a little bit neater to draw. I kind of go back and forth between them from time to time. So that is our graph. So we wrote and graphed the inequality described by the problem. Okay, here's one for you. Addison can bench press up to 94 pounds. Write and graph an inequality that describes the amount Addison can bench press. Go ahead and pause the video. Try it right now. All right. So I'm going to use A for Addison. You could have used B for bench press or whatever, P for pounds. So Addison's something with 94. Now, if they can bench press up to 94 pounds, does that mean more than 94, less than 94, up to 94? That means less than. Now, is 94 allowed? Up to 94. Could Addison bench press 94 pounds? Yeah. Up to means up to and including, like, so up to 94 pounds. So number line, 94, 96, 93, 92. And you're going to see me do this a lot as well. So I don't label every single little line because, well, first off, you probably noticed by now, my handwriting's not the prettiest in the world. So when I start getting a whole bunch of numbers in here, this looks sloppy to me. But I was doing it kind of for your benefit to see the numbers on the number line. I like this a lot better. I just label every other line. I'm still counting by ones, 92, 93, 94, 95, 96. But I don't have to label every single line. And that's okay with me. A lot of times you'll see on even number lines from a textbook, they don't label every single line. They'll skip lines, or they'll maybe count by fives or something. Okay, dot. At 94, I need a solid dot. Now, a trick you can use to help you see the difference between the solid dot and the hollow dot is the solid dot, the ones that are included in your solution, will always have this little or equal to line. That is really the difference between them. If we go back up to look at the circle type, the just less than and just greater than have the hollow dot. The or equal to get the solid dot. So that's how you can tell. That's how you can tell at a glance what type of dot you should be using, solid dot or hollow dot. Okay, so if we go back down here, we have our solid dot at 94. Shade. We want to shade the numbers that are less than, L less than 94. I had to think for a second of which way I wanted to do my graph, if I wanted to do the scribble or the wiggly. And I'm going to skip these for now. If you would like, actually I lied. I'm not going to do the first one. I'm going to do these two here. So could you take this graph and write it as an inequality? I encourage you to pause the video and try it. X is less than 8. It's just a less than, and we're shading numbers that are less than 8. X is greater than or equal to negative 2.5. So that's a way you can check to see your knowledge, to see if you are on the right track. All right, let's actually get to solving some equations or inequalities. So solving these inequalities will be exactly like solving an equation. So our goal here is we can actually treat this symbol like our equal sign. It's not an equal sign, but we can pretend like it is for now until we get to the graph. So if our job is to get the variable by itself, we are going to have to get rid of this minus 12. So we're going to add 12 to both sides because that is the opposite of minus 12. So k is less than or equal to 8. There we have it. That's a one-step inequality. Number line, 8, 9, 10, and there's a 6. So I'm skipping every other line. Dot. This is going to be a solid dot, and we know because of the or equal to line. And shade. This is a less than, so we're shading numbers to less than 8. But also, here's another little trick. I think we're ready for this now. So this less than symbol kind of looks like a little arrowhead pointing to the left. Imagine, see, it's like it's pointing this way. So less than will be shading to the left. Look, because these numbers are left of 8. They're also less than 8. And this just could potentially save you a little bit of brain power in the future. It's really not that hard, but if you struggle telling the difference between a less than and a greater than, that might be harder. Less than looks like an L, and you shade to the left. Less than, left. Number 10, letter B. So to solve this inequality, to get the p by itself, we're going to subtract 8 on both sides. So those cancel out, and p and 2. Number line, 2, 3, 4, and 0. Now, I just went ahead and told you that you can kind of graph the direction that the inequality is pointing. Like this looks like a greater than, right? So we'd shade greater than. Except that's wrong here. The reason why it doesn't work here is because the variable is on, we'll call it the wrong side. I'm going to use air quotes here that you can't see. It's on the wrong side. It's not necessarily a wrong side, but it's not as familiar to us, and some of the little tricks, like this trick, doesn't really work. So what we like to do is we like to take the variable and flip it so it's on the, air quote, correct side. We want it on the left-hand side. So I'm going to take the whole problem and flip it from this step. I could have flipped it from the beginning, but I'm going to do it from here. So I put the p on the left, the 2 on the right, but I also need to flip the direction of this inequality. Right now, it looks like it's opening and it's going to eat the 2. So when I flip it, it still needs to open like it's going to eat the 2. And now we can see that our shade is wrong. Our shade is facing the wrong way because now p is less than 2. We want the numbers that are less than 2, to the left of 2, not greater than. Okay, so when you're graphing or you're solving your inequality and you're going to graph, we always want our variable on the left-hand side. That is the side that's most familiar to us, and that's the side that's going to make our graphing the easiest. Okay, so honestly now, it's just going to be a whole bunch of the same type of problem. I mean, we've learned the lesson, now it's practice. It's sinking it into our brain. So I'm going to add 12, and I encourage you, if you want to work faster than me and see if you can beat me to the end of the problem, do that. That's 18. So I'm going to put 18, 19, 20, 17, 16. This gets a solid dot at 18 because of the or equal to, because of the little underlined line. This is a greater than symbol, so I'm going to be shading to the ones greater than. It also kind of looks like a little arrowhead pointing to the right. So we are going to shade to the right, which is the numbers that are greater than 18. Letter D. And I'm going to start picking up the pace. I think I've been going fairly slow for now. I think we're ready to go faster. I mean, you guys can solve equations and inequalities very well, hopefully by now. So if I'm going too fast, pause the video, slow it down. If I'm going too slow, heck, use the little gear thing and speed up the video. Go 2 times as fast if you need to, or if you're able to. So -7, -7, W, and that's -16. My variable is on the wrong side, so I'm going to flip it. I'm going to put the W here and the -16 there. And when I flip the direction of the inequality, I'm going to flip the symbol too. So now, instead of being a less than, it is a greater than. That's the one I want to graph from. -16. Paying attention to negative land. -16, -15, -14. And then this one would be -18. At -16, I'm going to get a hollow dot. There's no or equal to line, so this gets a hollow dot because -16 is not a solution. And I'm shading to the right. I'm shading greater than. All of these numbers are bigger than -16. You see? Fairly quick, fairly easy. Just like solving an equation up top, with the added step of graphing down below. Okay, here are 2 for you to try. Go ahead and pause the video, take a couple minutes, and do them right. When you're ready to continue, hit play, and we'll go through it together. Alrighty. So my +9, I almost did -9, +9 on both sides. H is greater than or equal to 21. So 21, 22, 23, and 19, that would be. Solid dot at 21 because of the or equal to symbol there. And I am shading greater than, which is to the right. Greater than to the right. Letter F, if I can zoom in. -4, -4. P is greater than 6. My greater than symbol's a little ugly, but it's okay. That's better. So 6, 7, 8, and that's a 4. I need a hollow dot at 6 this time because there's no or equal to sign. And since it is a greater than, we're still shading to the right. And there we have it. Letters E and F. Okay, more. We just need practice to make sure we sink this into our brains. So go ahead and pause the video and try these next 2. All right, hopefully in letter G here, you dealt with the problem that the variable's on the wrong side. So I would start by adding 5 to both sides. G and 20. Now my variable is on the wrong side, and I don't like that. I'm not going to graph from that. I'm going to flip my whole inequality. And right now, it's a less than symbol. It's like opening towards the G. When I flip it, it's going to become a greater than symbol. Still opening towards the G. That's the one I'd want to graph from. So then we got 20. 21, 22, and 18. We're going to get a hollow dot at 20. There's no or equal to sign. It's just greater than, hollow dot. And since it's a greater than, we're going to shade the numbers greater than 20, which are to the right. Greater than, right. Less than, left. Okay, letter H, let's see, minus 13 on both sides. This cancels out. W is less than or equal to negative 17. And that's done. So negative 17, I stopped myself to make sure I'm doing my number line right. Negative 16, negative 15. And then that would be negative 19. I need a solid dot at negative 17. And I'm shading to the left because this is a less than, to the left. And there's letters G and H. Applications. It says here that Tim must be at least 42 inches tall. My bad, sorry. Tim must be at least 42 inches tall to go on a roller coaster. Tim is currently 38 inches tall. Find the possible height in inches that Tim could grow and be able to ride the roller coaster. Okay. Now, that's a pretty basic question. I mean, these are still one-step inequalities, so they're going to be kind of very basic. I mean, you could probably go, oh, if he grows 4 inches. Yeah, that's one possible answer, but there's actually more than one possible answer. So here's Tim, and he needs to grow. So I'll make it Tim. Tim plus whatever height he needs to grow. He needs that to be something with 42. Well, he needs to be at least 42, which means 42 or bigger. Ideally, I mean, he could be bigger than 42 inches and ride the roller coaster. So now this kind of is my little verbal model. This just sets us up. So I know that Tim is 38 inches. We do not know how much he needs to grow. That's our variable. I'm going to use G for grow. You could also use like H for height or just plain old X if you wanted to. Okay, and if we subtract 38 on both sides, we're going to get G is greater than or equal to 4. So as long as Tim grew 4 inches or more, he could ride the roller coaster. Okay, so 4, just the number 4, is not just the answer. It's one of them, but it's 4 inches or more. So if he was 55 inches, he could ride the roller coaster. If he was 60 inches, 72 inches, he could ride the roller coaster. Another basic problem, but still, Sarah can carry up to 50 pounds. She's carrying a box that weighs 15 pounds. Find the possible weight that Sarah could still carry. Okay, so, I mean, I'm imagining Sarah, she's carrying 15, but she could also get some more, right? Like, she could add another box. So I'm just going to draw a box. 15 plus whatever, another box of stuff. She can have all of that weight to something with 50 pounds. Up to 50 pounds. Well, up to 50 means less than or equal to. So she can carry 50 pounds, she can carry less than 50 pounds, but she can't carry more. So 15 plus what gets us less than or equal to 50 pounds? Well, let's see. If I subtract my 15 on both sides, I'm going to keep the box for now. And then 50 minus 15 should be 35, but I'll use the calc. I haven't used the calculator yet this entire lesson. There we go, 35. So as long as this box weighs less than 35 pounds, or 35 pounds or less, she could carry it. So she could carry something that's 22 pounds and something that's 3 pounds, or a box that's empty weighs 0 pounds, up to 35, but no more than 35 pounds. Yoda is no more than 900 years old. If he's been training Jedi for 500 years, at what age did he start training Jedi? Go ahead and pause the video and try this one on your own. When you're ready to continue, hit play, and we'll go through it together. So, we're talking about what age did he start training Jedi? Okay, so Yoda is not more than 900 years old. So Yoda something 900. I'm just kind of brainstorming. If he's no more than 900, that means he's less than or equal to 900 years old. And if he's been training Jedi for 500 years, well, I guess I could just take 500 years off this, and I would get the age he started training Jedi. His age minus 500 would give me when did he start training Jedi. Okay. And, well, 900 minus 500 is 400. So he started training Jedi sometime before his 400th birthday. We don't know exactly when, but sometime before his 400th birthday, he started training Jedi. And summary. How do you know if the dot is a solid or hollow dot when graphing the inequality? What's the difference? Go ahead and think for a second. How do you know the difference between them? Well, if you have a just less than or greater than, you have a hollow dot. If you have one of the or equal to's with an extra little line underneath, like these two, that is your solid filled in dot. And that's how you tell. You can look directly at your inequality. You also know that this number is part of the solution because it's in the shaded region, where the just greater than and less than, that number is not a solution to the inequality because it's not in the shaded region. Thank you so much for watching this lesson, and until next time, toodles.